Experiment 16 and 17 continues our series of experiments on qualitative analysis, specifically the qualitative analysis of cations in an unknown aqueous solution. We started this back in experiment 5. If you have a solution that could contain one or more of all the different possible cations that could exist in a solution, what we try to do to analyze the solution for what cations exist is to precipitate out small groups of them at a time. And the first group that we precipitated out were the insoluble chlorides, and we did this by adding the precipitating agent, hydrochloric acid. This caused 3 precipitates to form if all cations were present. Those would be silver chloride, mercury 1 chloride, and lead 2 chloride. And in experiment 5, we learned how to separate and analyze this particular precipitate for the 3 possible cations. Once they've been separated, the remaining ions that stayed in solution needed to be broken down into smaller groups again. And in experiment 13 and 14, we did this by adding hydrogen sulfide as our precipitating agent. But because the sulfide ion is the anion of a weak acid, we could adjust the sulfide ion concentration by adjusting the pH. So in experiment 13 and 14, we made the solution very acidic. We made the pH very low, and that caused the sulfide ion to be very low as well. With a low concentration, it did not precipitate out all of the cations you would expect to be insoluble with sulfide, but it only precipitated out copper 2, antimony 3, and bismuth 3. And experiment 13 and 14, we took that black solid and we went through a series of steps to analyze for those 3 specific cations. We found that in a basic solution, the antimony ion formed a complex ion, would become soluble, and then eventually, with the addition of sodium thiosulfate, we were able to turn that colorless solution into a pink precipitate, indicating that antimony ions were present. For the copper 2 sulfide and the bismuth 3 sulfide, we dissolved that precipitate or those precipitates in nitric acid, and then we added ammonia. We found that the copper ions would form a bright blue complex ion with ammonia indicating its presence. The bismuth would precipitate out as bismuth 3 hydroxide, and we proved bismuth was present by reducing the bismuth 3 ions into bismuth metal, which turned black. In experiments 16 and 17, we're now going to take the remaining ions in solution on the very right of our flow chart here, and we're going to separate out the third set. This is the third qualitative analysis group, still with the same precipitating agent, hydrogen sulfide, but we're going to adjust the pH to be a basic pH, which increases the sulfide concentration and precipitates out the rest of the ions that are insoluble with sulfide. So today's precipitating agent is going to be thioacetamide again to produce the hydrogen sulfide, which gives us our sulfide ions. But with a combination of ammonia and ammonium chloride, we're making a buffer of a solution that has a high pH, a basic pH, and that'll precipitate out 4 cations for group 3. Iron 3 will precipitate out as a hydroxide in the basic solution, and then cobalt 2, nickel 2, and zinc will all precipitate out as sulfides. And we're going to take these 4, and in today's experiment, we're going to learn how to separate and analyze for those. It's really important the order we're doing this in. In the qualitative analysis scheme, the first thing that's separated is always the insoluble chlorides, silver, mercury 1, and lead 2. Because if they're not separated first, if you go to group 2 and you add hydrochloric acid and thioacetamide, the precipitate you would get would be the copper, the antimony, the bismuth, and silver, mercury 1, and lead 2. So the order is important here. Group 1 cations must be separated out first with HCl. Then group 2 cations must be separated out with thioacetamide in an acidic solution, because if you don't, and you go to step 3 and you add thioacetamide in a basic solution, your precipitate will be the iron 3, the cobalt 2, the nickel 2, the zinc, and the copper 2, antimony 3, and bismuth 3. So in today's experiment, we're going to once again find that if we're going to wind up dissolving these precipitates in a mixture of hydrochloric acid and nitric acid called aqua regia. And once they're dissolved, we're going to find once again that one of them will form a complex ion at the beginning of the experiment. If we make the solution basic with sodium hydroxide, we find that zinc will form a complex ion with hydroxide, And eventually, when we add potassium hexacyanoferrate, we're going to be able to make that colorless solution turn into a green solid to indicate the presence of the zinc ions. Of the 3 remaining cations that do not dissolve in sodium hydroxide, that would be iron 3 hydroxide, cobalt 2 hydroxide, and nickel 2 hydroxide, we're going to dissolve them in a combination of sulfuric acid and hydrogen peroxide, and then we'll take this solution and divide it into thirds, and each of them will test with a specific reagent that would produce a significantly colored result indicating the presence of either iron or cobalt or nickel.